Hey everybody, it's Mr. N here. We are going to do this next lesson on similarity and transformations. Basically, this is just accumulation of what we've done, and it's just pretty much a review type lesson. So let's get into it and talk about some of these things. All right, so let's get into this. Let's slide this up a little bit. Starting with our notes here, it says a transformation that produces similar figures is a similarity transformation. So something that produces similar figures, we're going to be talking about basically a dilation. Or we can have a composite of one or more dilations and one or more congruence transformations. So two figures are similar if and only if there is a similarity transformation. We've talked about dilations. We know that there's a scale factor. We write them as a dilation about our point of origin. In this case, it's the origin, about a point. And this will refer to a dilation with a center O and a scale factor K. We said that if it's greater than 0, then it's going to be longer. If it's shorter than 0, then it goes in the opposite direction if it's less than 0, right? If it's less than 0, it goes in the opposite direction. We have the absolute value. If that K, the scale factor, is greater than 1, it's an expansion. If it's less than 1, it's a contraction. All of this we've done in previous lessons. So this is not new. That's why I went through this pretty fast. And we know a dilation is not an isometry. Okay, so we got a couple things here. We know that a dilation preserves angle measure. So even if you change the side, the angles will stay the same. It preserves betweenness, whatever stays between. So if like over here, if I say I've got point A, I've got point B, and I've got point C, and I've got some sort of line, and over here, point C, and I've got point A, and I know that point B is between them, even if I enlarge this line and make it bigger, point B will still remain between wherever A and C are. Okay, and dilations preserve collinearity, so things will remain collinear. A dilation maps a line not passing through the center of dilation to a parallel line and leaves the line passing through the center unchanged. The dilation of a line segment is no longer or shorter than the ratio given by the scale factor. All right, so we know all these dilations maps congruent angle, any angle to a congruent angle. This is all stuff we've talked about in the previous section as well. It'll be K times as long, absolute value, that's our scale factor, and the area, that should say, as we fixed in the previous chapter right here, this should say area. Can't write today, is K times as large. Okay, so none of that has changed so far. All right, let's and take a look at all we have to do. We're going to be doing a bunch of these right here in the student journal in class, but I do want to do a couple problems here with you from this, which will be our warm-ups, but I still want to do a couple anyway. Okay, so I do want to review one of these rotation ones. So take a look. Say we do number 2 over here. Okay, so let me change the size of this. It's a little big. Okay, so suppose we do a rotation about the origin -45. It says come up with another name. So -45, all we have to do to this is either add 360 or we can subtract 360 to come up with another name. So that would be a rotation about point O of, in this case, if I add the 360 to it, that would be 315 degrees. So I can write it like that as well. I could subtract 360, so I could say another answer to this is a rotation about the origin, and this would be 405 degrees. So now I do want to remind you that here, this other one I want to go over, this one right here, right? When you have H and then sub-0 like that, that's a half turn, right? So H, we had said this stands for half turn, right? And so when we do a half turn, that just means about the origin right here. Half turn is, we said, 180 degrees. So that means E will go 180 degrees. Remember, counterclockwise is this direction, but it doesn't matter because it's going to be 180 anyway. So that would become point A. Okay, so I do want to make sure you know that, just to make sure. Now, I do want to do another one down here. Let's take a look at 16. 16 says, okay, we need to, and let me pick another color here. We need to do a dilation about point B by a half. C becomes what? All right, so let's take a look at this. Here's C, but now I'm dilating about point B. Let's use this to show you that it's point B. I'm not dilating about the origin. So when you take your distance, you are not going to take it from O. Normally we would have say, okay, if I dilate about the origin and I'm doing a half, I would say here's point O. I would go 1, 2, 3, 4, 1, 2. So that means I would do half of that, 1, 2, 1, and that would be my new point right here, correct? But we are not doing it about the origin. We're doing it about point B. So now I need to take my distance from point B. So over here, this distance is 2, and I don't have a y distance. I'm going to take half of it, so that would put my new C prime right there, and that's at the coordinate 4, comma, negative 1. Okay, so there is a difference there, and that's because I'm going about point B rather than the origin. So the answer here, C becomes the coordinate 4, negative 1, comma. Okay. So the rest of this we are going to do in class to make sure you understand it. I'll do one more for you here for like number 18 on this one. It says find the scale factor of the dilation, right? State whether the dilation is expansion or contraction. I'm going from 3 to 9, 0 to 0. So that scale factor K is going to be 3, and right, it's getting bigger, so this is an expansion. Okay. All right, so that was it. It's a quick video today. Again, a lot of it's review. We're going to review it in class. If any of this may have seemed a little bit difficult for you, go back and watch the previous videos on dilations, on rotations, on translations, because this is kind of a summary of everything. All right, thanks for watching. Hit that like and subscribe button, and I'll see you guys in the next video.